Hi, welcome, good back. Welcome, good back. That made no sense. Welcome back. I'm here at my conference hour. I've got a couple people in-house, so this won't be so super stale. But we are going to be working on circle vocabulary today. And so let's go ahead and take a moment. Notice this is the notes from before where we were doing the walkthrough. This is just the very next page. Again, I'm leaving it up to you if you want to do a KWL for your assignments. Remember, KWL standing for a question that I knew how to do, a question that I worked really hard on and got correct, and then a question that I learned a lot from. Ooh, blurry. There you go. So you are welcome to do that, in which case you'll have a extra page above what I do here. I'm cutting this video on the 22nd of March, here 2006, and we're just updating our title here with our what objective and our how objective. Those both objectives are on the right hand side of the screen in case you can't read my terrible handwriting, and I think my hand is covering part of it. Anyway, we are going to be learning some vocabulary today for circles, and we're going to be doing that by saying, writing, and drawing different circles, of course, because this is all about circles. We're also going to be drawing some segments and some lines and some angles and all sorts of fun stuff. So that's what you can look forward to today. You might want to consider getting a straight edge of some kind, so that way you can draw. I'm going to grab this little thing I found here on my desk, this little shape here, and I'm going to use that as a straight edge today because I don't have to draw very big lines. Again, set yourself up for note taking, so give yourself that left hand section there. And let's go ahead and start this off with our first big vocabulary word for today. I'm going to try to do something a little different. I'm going to put a bar right here. I'm going to highlight in pink to show that this is an important vocabulary word. I know that some of you have been having trouble recently trying to find definitions of things, so I'm going to try to help you guys out. Let me know in the comments if this works for you. So let's find the definition of a circle. We'll define a circle as the set of all points in a plane. So these aren't floating around three-dimensional. This is on a single surface like a sheet of paper or the top of your table. And these points are a set given distance from some other point that's also on the plane. And intuitively you might have a sense of this from when we drew it with our compass. You had the compass needle staying in one spot, and then you had the compass pencil kind of tracing this circle figure all the way around, and it was the same distance because this radius never changed. It's going to look something like this. We kind of try to draw freehand a circle. It doesn't have to be perfect or beautiful. Just give it a quick sketch, something that kind of looks like a circle. We do have a symbol that I'm going to be using to denote a circle. It's going to be a circle, fancy that, with a dot in the middle, and then you're going to write a capital letter in the middle, right after it. What that capital letter is the name of the point that is in the center of the circle. So since this circle has a center point A, we'll write its name as the symbol for circle and then the letter A after it. It needs to have both parts in order to be the symbol for the circle. This symbol is read circle A, and it means the circle with center A. I'm not sure where I'll write that. I don't think I'm going to. Okay. We can write an equation for a circle, so if we put this on the Cartesian plane, that's our XY plane, so something like this. We could put that circle here, and we'd have its center somewhere. I don't know where it is, but there it is. Not on the origin, obviously. We would write the equation this way. R equals, R squared equals, in parentheses, x minus h squared, adding to that y minus k, also squared, also in parentheses. This equation looked really, really weird, doesn't it? But it comes from something very familiar. We can actually generate this equation. Let's write this down. We can generate the equation of a circle from nothing more than the distance formula. Oops, I forgot a word in there, didn't I? Here's how we do it. We're going to start with the distance formula. So in this case, we're going to have D stand for distance. And here was our good old distance formula. You remember this guy? A little bit. I'll put a link, remind me, I'll put a link either in the description or as a card to the distance formula. So there it is. And then what I'm going to do is I'm going to substitute a whole bunch of stuff. So instead of distance, I'm going to say r, and I'm going to let r be this distance right here, r. Okay, the distance from the center of the circle to some point on the outside of the circle. That will be r. And then I'm going to have everything the same, but instead of x2, the second x coordinate, I'm going to write just x. And instead of x1, I'm going to write h. Now, hopefully this h and this k are somewhat familiar to you. They actually come from translations. So this h and this k are some sort of horizontal and vertical shift. They're a translation. Now to get to our final equation, I'm just going to square everything in order to get rid of that very pesky square root. So when I square both sides of the equation, the right-hand side loses its radical because a square is the opposite of a square root, and the left-hand side gains a square. Okay, so that's how we can generate the equation of a circle in standard form from the distance formula. We're going to put a quick recall here, so please recall that h and k are translations. Well, I'm going to run out of space. All right, so now that we've talked about a circle, we want to take a moment to talk about what this mysterious letter r is that we were using in its equation. R is what we're going to use to represent the measure of the radius of the circle. We had said that r was representing the length up here of this line that went from the center to some point outside. And so we'll define a radius as some segment where the endpoints of this segment are on the center of the circle and on the circle. Let me catch up to my speech here. All right, there we go. We can say more than one radius, and when we have more than one radius, we'll make the plural of radius, and the plural of radius is radii. Greek. Fun stuff. Okay, so we have radii. I am leaving this space here to the right-hand side blank because I'm going to put a picture in there in a little bit. So please make sure that you're reserving that space for yourself. While we're here, we're going to go ahead and talk about a chord. This isn't the chord for music, all of my music fans. This is a geometry chord, and what a chord in geometry is it's a segment where the endpoints are on the circle. Okay. Here we go. Let's draw a picture of the radius really quick. Here's the radius. There's a circle with its center. There would be a radius. There's a lot of different ways to draw a chord, but really you would just want to make sure that you get some sort of straight segment and that it goes from circle edge to circle edge, kind of like that. All right. The next segment that we can find in circles is called the diameter. I'm going to draw a picture of that diameter here for you after I give you the definition. A lot of you may already have an intuitive sense of what a diameter is, but I want to give you the very specific definition. The diameter is a chord, so it's going to be a segment with endpoints that lie on the circle, but it also is going to pass through the very center of the circle. So a diameter is going to be a chord that passes through the center of the circle. It's also made up of collinear radii. Recall what collinear means. I'll have a card or link somewhere for you on screen that'll take you to where we talked about collinear way back in semester 1. So here are 3 kind of big definitions of different parts of a circle, the important bits of it. And since these are all definitions, I'm going to go ahead and take my pink highlighter here, and I'm going to highlight the edge of my paper to see that those are definitions. And let's go ahead and fill in this space. So if you'll take the rest of the space here on the right-hand side, draw for me a nice big circle, give it a center, name it L, and then draw a chord naming I and O. There's our, oops. We're going to put it there now because I kind of missed. And then draw a diameter for me. There we go. Name that diameter N and S, and then draw some sort of random radius R. What you need to do for me for a notebook check is to name all the radii that you see on this particular figure. Then I need you to name all the chords that you see in this particular figure, and then name all of your diameters that you find in this particular figure. So this will be a notebook check, part of your grade, so make sure that gets filled out the next time you come into class, and I'll be happy to score that for you. All right, we've got a way to talk about different pieces of a circle, and in fact we know the radius, which helps us define our circle, because that is the distance from the center point to any point on the outside edge of the circle. This allows us to talk about 2 different types of circles. This allows us to talk about congruent circles and concentric circles. We'll give you the definitions of each of those. So congruent circles are going to be circles that have congruent radii. Yeah. Hang on, where did I put? Yeah, with congruent radii. That's all. That's all they need. Congruent radii. So you're going to have one circle sitting over here, and he's got a radius BA, and then you have some other circle sitting over here, and he's got a radius of, I don't know, CD. And as long as we have BA being congruent to CD, that will allow us to say that these circles, circle B and circle D, are congruent to each other. Concentric circles, on the other hand, are going to be circles that do not have congruent radii. So we're going to say incongruent. So circles that have incongruent radii but have the same center. So these circles are going to look like this. It's my daughter's favorite store because they sell a lot of Skylanders. Because it looks like a Target symbol. Get it? Okay. So these are definitions. We're going to go ahead and mark those down right there as definitions. And I'm out of room on this page, so I'm going to go to the next page and set myself up to take some more notes. There we go. All right, so the next vocabulary that I really want to talk about for circles is the circumference. I'm pretty sure that you guys are like, oh, I know what a circumference is. And then I go, what is it? And you go, I don't know how to put it into words, but I know what it means, sort of, and you can probably show me. But let's give you that very specific definition. The circumference of the circle is the distance all the way around the circle. It has a formula. That formula is found right here. We can write it two different ways. We're going to use capital C to denote circumference of the circle, and that is this mysterious number pi times d for diameter. Now we have to be careful because we had a d earlier meaning distance. This d is talking about diameter, so I'm going to try to make this one look a little more cursive-y than the other one. Or you can use the formula, capital C for circumference is the same as 2 times pi, again pi is just a number, times r, which is the measure of the radius. Okay, we'll do some more problems soon regarding this, the circumference, and we'll be playing with it a little bit later with our definitions. Okay, let's move on from talking about the outside characteristics of our circle, lines and the distance around the outside, and let's talk about some angles that we can find inside of our circle. So the first angle type that I want to talk about today is called the central angle. And the central angle is going to be any old angle with the vertex sitting on the center of the circle. Whoops, I forgot a word. With vertex at the center of the circle. This is supposed to be an N. I think I'm nervous all of a sudden. And the side of this angle, both sides, are going to contain chords. So go back to remind yourself what a chord is. So chord is a segment where the endpoints are on the edges of the circle. And so the central circle is going to look something like this. I have this circle C, and I have two chords like this, and so this is the central angle. We can talk about how to find the measure of that, but we'll do that later. I'd like to first use this word in a sentence for you. So in this diagram, angle ACT is a central angle of circle C. Okay? We'll talk about how to calculate the measures of those angles on our first walkthrough for this section. To gear up for that walkthrough, I'd like to show you how we can find the sum of central angles. We do that this way. I'm going to do it in words, and then I'll show you a picture and give you the equation. In words, it says the sum of the measures of the central angles in a circle that have, how do I say this, that don't overlap. Those central angles aren't allowed to overlap each other. I'll draw it so you can see it. That sum is 360 degrees. So here's my messy circle. Let me actually bust out my straight edge. I said I was going to use it, and then I never did. All right, so there we go. There's our circle. We have our three little chords here, so our three angles, and I'm going to go ahead and label my circle. So here's one angle, LIO, and so the measure of that angle plus the measure of this angle, OIN, so this angle right here, plus the measure of this angle right here, NIL, is going to equal 360 degrees because we went all the way around the circle. Okay? Nothing too complicated, yeah? Okay. This happens regardless of the number of central angles that we're dealing with here. So right now this picture has 3 central angles. You could have, I don't know, 4 million central angles if you wanted to. This little property here is going to hold for you. Since this is a property, I guess I'll color it in yellow. Okay, so it's slightly different. All right, so we have these central angles, and notice how I was marking in here. But notice how that's kind of the same as if I had marked out here along the edge of the circle. So we can talk about that portion of the circle. And that piece of the circle is called an arc. An arc is, as we stated, a portion of a circle which is defined by 2 endpoints. I think I misspelled a word in there, I'm sorry. So it's going to look something like this. So I have a circle sitting right here. I have the center, I guess we'll call it F. I've got some point L and another one H and some other point over here, S. Okay? We're going to pretend that that's one straight line. So we have a figure that looks like this. There are 3 different types of arcs that are created when we have a setup that looks something like this. We have the semicircle, which is an arc whose endpoints are the diameter. So it's half a circle. The semicircle is an arc whose endpoints, sorry for writing kind of small here, are the endpoints of a diameter. Remember that diameter was a chord that went through the center of the circle, which meant its endpoints are on either side of the circle, and it goes right through the middle of it. Wow, that was written kind of small, sorry. We have the minor arc, and this is an arc smaller than the semicircle. So we're comparing it to the semicircle. And then we have the major arc. And this is going to be an arc larger than the diameter. Or excuse me, semicircle. Okay, so let's take a moment right now, since these are a little more challenging to see, and let's list out all of these semicircles that we see here. Okay, and this way you can get the symbol for arc. So we need to find a diameter. So here's a diameter. It goes through the center, mostly, we'll pretend. So one semicircle is going to be here from L to S. And it goes through H, since we have this point here. So we're going to go ahead and state that it goes from L through H to S. So I'm going to write those 3 letters all next to each other, L, H, S. But I'm going to put a little rainbow over it to show that this thing is an arc. I also have this one down here that goes L through S, but it doesn't go through H. Actually, there's no point that it goes through here. So it has to be just this one, and I can write it as just LS. And again, write the little arc symbol above it to show that it's the arc part of a circle. Okay, let's go ahead and take a moment to list I'll list a few of the minor arcs, and I'd like you to take some time to list out more. Remember that these need to be smaller than the semicircle, so it needs to be smaller than half the circle. So if I look up here at the top, I see arc HS. There is another minor arc, so please feel free to take a moment, fill that out. I'll use that as a notebook check that you have completed that item. Let's go ahead and take a moment to list all of our major arcs. Remember that major arcs are going to be larger than the semicircle, so you need to start at some point, make sure that you go past the halfway point, but don't go all the way around. We don't want to name the entire circle, we just want to name a portion of it. And if you notice, I started at H. If I go this way, I go through L, and then up and stop at S. So H, L, S, starting at H, going through L, coming around to S. That is going to be one of my major arcs. There are more major arcs, so please take a moment, fill that out. I'll be using that as part of your notebook check. That is part one of circle vocabulary. There is quite a bit more vocabulary to go through for circles. So please stay tuned, watch for the next video that should be coming out shortly, in which we continue with circle vocabulary. Thanks again.